Yes, welcome to this session. I would like to bring to attention for CNC machinists just a simplified guide for threading. I think yesterday I checked on how to part between TPI and also each millimeter. We had a table and the formula to use. Today we want also to look at the terminologies which are used in threading or typing, as also the identification codes for easier programming. So when you're doing CNC programming, you're able to understand how to relate these codes. We normally have what we call UNC. UNC is a standard threading definition, which stands for Unified National Course, in the sense that it's used, normally it is from US, that's a US standard, meaning it has a coarse pitch. This is normally stronger root, better for soft materials, and also quick assembly, normally commonly used in construction and general engineering. Also those threads we call them UNC. Then you have another category called UNF. So UNF is also a US standard, but it's normally for fine pitch. That is Unified National Fine. So these are more thread per inch, which provides stronger clamping and better vibration resistance, and it's normally used in automotive, aerospace, and also precision assemblies. Then another category that is common, maybe we have only put 4 categories or 3 categories. The remaining also bring to use or some other categories for threading. We have what we call NPT. NPT is a national pipe taper, which means it's tapered to an angle for 1 degree and 45 minutes. So you're able to convert 45 minutes to degree. That is 47 divided by 60. You're able to get a value close to, let's check, we divide, that is 47 divided by 60. So you get almost 1.8 degrees, which means it has a taper angle of 1.8 degree, designed for sealing. Normally the male threads have like a wedge which enters into female to create the seal. They are normally used in for fluids or gaseous or hydraulic systems. We call them the NPT. Then we also discuss the formula. For example, if you are converting from maybe pitch in millimeter to TPI, how can we go about it? And this is the formula. If you are converting them, maybe pitch in millimeter to TPI, you just take, because one inch equal to 25.4 millimeters, so you take 25.4 divided by 1.5, you get 16.93. Or if we're looking at them, let's say 2, I use this formula, I'm able to calculate this automatically. These are just a custom formula I have put for my calculation or my use, because I'm a CNC machinist. So when I'm doing the machining, in case I want to convert now from maybe TPI to inch, or maybe TPI to millimeter, or millimeter pitch to TPI, I'm able to use this formula to calculate. Okay, so the best formula you can use is just to take 25.4 divided by TPI, or thread per inch. Then if you are using in inches, you just take now 1 divided by TPI. Also can give you the lead for the single start screws. I also put a master table. Ensure you as a designer also or a machinist, each time you are designing for assembly and machining, or each time you are doing machining, you need to have a master design thread guide to guide you on what is supposed to be done. I may not explain all of this, but you understand these are now the TPI 4/40. So the TPI here is 40, the TPI is 40. This is UNC, which means it's Unified National Course. The major diameter is close to 2.845 with a major diameter of 2.011, and then the pitch is this. So you take 40 divided by 25.4 divided by 40, you get 0.6350 as the pitch in millimeter, which also has a pitch in inches, which is close to 0.02500, and this is conversion or equivalent to metric. You may find this as M3 by 0.7 or 0.5, close that. And then we have other categories. This one now, the chart you can refer. Maybe somebody has given you to make a thread of maybe, let's say, 1024 UNC. So you need UNC is national unified national course. So you have to check the major diameter, the minor diameter, and also the close range for either if you are using isometric or you are using the TPI to do threading. So this is a chart you can use. Then I have also provided a simple chart for metric. Maybe I will share this file for those who wish to follow the file. I shall share the file. For the metric also, you have, for example, M4, M5, M6. These are now the ISO standard, where the major diameter is 4, then the minor diameter is 2.9. That is 4 minus the pitch, you get close to 3.3. But because normally the ISO standard has an allowance, so the 2.92 is okay for straight threads. These are an example for ISO. Then an example for NPT, that's the taper for sealing thread. You can have, like in hydraulic, in a gaseous system or pneumatic systems, be able to use NPT thread. So, like for example, 1/8 to 27, you will be able to find the TPI of 27, so you can convert the pitch as 0.9 for 0.9407. So this, you can now use this one when you're cutting your thread. But remember, the angle, tapered angle, is normally for liquid or gaseous, normally 1 degree for 7 minutes, or you can convert minutes to degree, which is close to 1.8 degree. And then also, when you are also doing threading, you need to know the sizes you want to drill. For example, if you are using maybe, let's say, TPI of 4 by 40, so you need to know the drill type is for 3. So here you are using the drill type of 14 inches, but in millimeter it should be 2.26. So this one will help you to know how to put the thread so that it is able to fit accordingly. So this is also a chart for tap drill sizes reference. You can get the table design from most of the manuals when you're designing, also when you're doing machining. So because most of the programming manuals will not give you the chart, but you need to understand the difference between the NPT, UNF, and UNC when you're doing threading, and also ISO. And then also for UNF, I also provide the chart. You have a chart here for UNF threads. If you want to do how much is the pitch, how much you need to do to drill in inches or in millimeter. So this is a simplified chart which can help us to do threading. For example, if you're doing M4 by 0.7, which means the pitch is 0.7, and then the minor diameter will now take 4 minus 0.7. But remember, it's ISO, it has some allowance, so you need to understand the kind of allowance I'm going to put, so for what you put the right thread. So this is an example. So you need a drill bit of 3.3 to do a 3.3, then you can do it at tapping. That you can do tapping. For M5 by 0.8, you need to do a drill 4.2. For M6 by 1, you need to do a drill by of 5, so that you can do now a tapping of M6 by 1 as it goes. So this is how you calculate. You just take the major diameter minus the pitch, you get the size of the hole you need to drill. For NPT also, I've given you a symbol for NPT. For example, maybe NPT 108 to 27, that's the TPI is 27. So you take 25.4 divided by 27, you get the pitch. From there, you minus from the 1/8, you get the required diameter for each one of them. So these are the example you can use for threading. So normally for threading, as I said, explained here in our previous guideline here, there are various codes you can use for threading. Some of them may require to put the right parameters. For example, if you're using G76 for threading, you need to understand G76, the purpose of G76, where do you require to put maybe the min number of passes, maybe the pull out or the chamfer, the cutting angle, minimum depth of cut, the finishing allowance. And also this will come to maybe this formula will help you, because when you have the pitch calculation, normally the pitch is equal to 25.4 divided by TPI. You get the pitch in minute. Then here now the feed rate will be almost normally the machine, because you don't need, for doing threading you don't need to put the pitch. As you can see in this example, maybe I can show you an example here. Here in this example, there's no pitch put here, so you don't need to put the pitch. You only put the spindle speed. Then because the machine will now synchronize as the pitch, it will be using that filter as a pitch to cut. Then you have the what you call thread height. You need to also find the unified height for each one of them. Normally you can take 0.6495 times the pitch if you are doing finding the unified H or the thread height. An example, for example, this one also you can check, or for this is for normal, or this is for unified thread, or for ISO you can use now 0.6134 times the pitch to get the height of the thread. Then the depth per pass, normally I had given you a simple pass. How you can compute the passes for each one of the thread. The passes for each one of the thread you're doing threading. There's a chart I've given you previously for the passes you're doing thread. How do you calculate the passes? I think it was the previous session where I was explaining how to calculate the passes. I will show you. But this one normally for the first pass you can take maybe between 25 to 30% of the thread height. But now you can start reducing the subsequent passes, maybe to again to have 2 or 3 spring cuts. And then you also need to understand which kind of G code you're going to use depending on your machine. There are various G codes for threading. As I already explained, the main G codes you have may use either G92, G93, G76, G82, G92, G96 and N7 together, so that when you are putting the program is going to be compatible. So that you understand what is required in each of these programs. For example, like you're using G76 as a cycle for thread cutting external, because normally it's a 2-line. The first line you need to put the cutting parameters, the second line you need to put the control parameters. So all of this one you have to ensure that you calculate in the right manner. Then you're putting the thread will be standard. For Siemens, normally the Siemens machines they normally use Cycle97. If we're doing longitudinal thread, we use Cycle97. Just another example. Put also the cutting parameters. You need to understand of each of the operations depending on the material. Which one are you going to use? Maybe ISO standard material for steel or medium carbon or whatever. Depending on the material, you need to understand if you're doing facing, what kind of cutting speed you need to use. Because this one I already explained in my previous session. The kind of feed rate you need to use, the kind of depth, how much depth you are going to go inside. So each one of these material will be very good for you when you're programming. That at the end of the day, you need to give a client a quality work. So understand the cutting parameters, understand the right tool for threading either ISO or for threading either UNC or UNF or NPT. So this is very important. I've also put the cutting parameters for the thread. For example, if you are doing a thread pitch between 0.5 to 1, this is the spindle speed you can use. If you are doing a pitch maybe between 1.25 to 2, you can use spindle speed of 300 to 600. If you are doing a thread pitch of 2.5 to 4, you can use the more the pitch, the lesser the spindle speed. So that's what it means. Also, it may be same as feed rate for the feed, which is close to what you have already given you in this upper chart. And then depth of cut for the first pass, it can increase depending on the pitch. When a pitch increases in the first, depth of cut also increases. Okay. Then also you need to understand how you are going to identify the tool. Normally, it's good to know the the CNC insert you're going to use. Maybe, for example, if you're using DNMG for turning, DNMG maybe 120404, you may find the first number is define the shape of the insert, and normally it's called 55-degree diamond. The second number may define the relief angle. Here it means it's -0. The third number will define the tolerance or the medium allowance. Then the G, or the fourth one will explain the G breaker and also the whole type of the tool, which means this G is double-sided, universal. And then we have what we call this now a negative insert. Then you have 12 we denote the size, that's inscribed cycle, which is 12 millimeter. Then 04 here it is define the thickness, which means normally close to 4.76 millimeter. Then last code 04 defines the tip radius, which is the corner radius, which is 3.4 millimeter. So each one of these is very important, so that when you select the tool, you need to match with the right holder. This may be your insert. For example, these are the positive insert, because they don't have the negative angle. These are called the positive insert. So this positive insert, when you're using them, you need to understand how to match together with their holders. DCMT is a positive insert, DNMG is a negative insert, VNMG, TNMG, WNMG. So these are DNMG is a negative insert with an angle of 55-degree diamond. This is angle for 35 degree, this angle of 60, and this is an angle of 80. This is trigon shape, called the trigon shape. They are strong, double-sided with high feed capability, because they can be used for roughing. So each one of them is very important when you are selecting the tool. So you need to understand the positive insert and the negative insert. The positive insert may only cut on one side. That's why it doesn't have G here. But the negative insert can cut with both sides. So they're normally strong as compared to the positive inserts, because depending on how they are produced, either through powder metallurgy, chemical, or powder way of forming them. So this is a simplified version of what you need to require you as also operator when you are doing your machining, especially for threading.